Hello friends, welcome back to Online Math Up. We have this question right here. So this is 1 power x is equal to negative 3. Okay, so we're going to be solving for x, and so we're able to find out the value of x that will satisfy this equation right here. Okay, so one of the basic things I can do at this point is just to take the natural log of both sides so that I can be able to bring down this unknown. So if I do that, I'm going to be having the natural log of 1 power x, okay, is equal to the natural log of negative 3. Okay, and then of course using the property of natural log of a power b, you can actually use b to multiply the natural log of a. Okay, so that if I bring this one down, I'm going to be having the x multiplied by the natural log of 1, and is equal to the natural log of negative 3. Okay, and at this point you actually see that there is a problem because natural log of 1 is 0, and then 0 times x is equal to 0, but of course 0 cannot be equal to natural log of negative 3, because of course natural log of negative 3 is not even defined. So we've got into problem, and then what we need to do next is just to find a way to extend our solution to that of the complex numbers. Okay, so what we're going to be doing is just to find out some representations of these values so we can be able to make some substitutions. Okay, so to do that, you remember the Euler formula, which is exponential I theta, which is defined as cos theta plus I sine theta. Okay, so if we actually substitute 0 for theta right here, you're actually going to be seeing that exponential 0 will be equal to cos 0 plus I sine 0, and of course sine 0 here is equal to 0, and then cos 0 is equal to 1. So obviously you can see that when theta is equal to 0, this exponential equation now becomes equal to 1. This is not just going to be happening for 0 alone. So when you substitute theta equals 2 pi, okay, you also see that exponential I 2 pi will still give you a similar thing, because of course this will give you cos 2 pi plus I sine 2 pi, and this term here will still be equal to 0. Okay, 0 multiplied by I is same, and then cos 2 pi will still be equal to 1. Okay, so this is 1. Good. And then of course you see that exponential I 2 pi will be equal to 1. If you also check exponential, let's see, 4 pi, you will still see that it will be equal to 1. So that in general, when you check exponential I 2k pi, okay, this is actually going to be equal to 1 for all integer values of k. Okay, now from here we can actually go ahead to make the substitution. That is, whenever we see 1, we can substitute exponential I to k pi. Okay, so if we do that, the question we have got at the beginning, which is of course 1 power x equal to negative 3, we now change to exponential I 2k pi, and then multiply by this x right here, will be equal to negative 3. Okay, and then of course I can use this x to multiply the stuff inside the bracket, and if I do that, I'll be having exponential I 2 pi kx. Okay, this I is equal to negative 3. Okay, so what we had is exponential I 2 pi k, or 2k pi x, is equal to negative 3. So taking the natural log of both sides, I'm going to be having natural log of exponential I 2k pi x, okay, is equal to the natural log of negative 3. Then using the property of natural log, I'm actually going to bring this power right here down. So I have I 2 pi k x natural log of exponential is equal to the natural log of negative 3. Okay, and of course, natural log of exponential is equal to 1. Okay, so I'm going to be having I 2 pi kx is equal to the natural log of negative 3. And at this point, we can divide through by the coefficient of x, that is I 2 pi k. Okay, I 2 pi k. So that if this cancels this, obviously x is now equal to the natural log of negative 3, and then divided by I 2 pi k. And don't forget, this is actually going to be happening for all integer values of k. Okay, but we're not done yet, because of course I cannot be here. So what we'll just need to do is to multiply through by I, so that we can remove the I at the denominator. And if I do that, this I times I would be equal to minus 1. So I'll push the minus up. Okay, minus I multiplied by the natural log of negative 3. Okay, so this is what we're going to be having, divided by 2 pi k. And then next thing we want to actually evaluate, because of course the natural log of negative 3 does not exist, so we still want to find a way to express it in complex numbers. Okay, so we can actually write this as natural log of negative 1 multiplied by 3. Okay, so using the property of natural log, we can actually sum this, that is the natural log of negative 1, and then plus the natural log of 3. Okay, so our job is just to represent this negative 1 in complex numbers. And then if you remember the exponential, the polar exponential equation we considered earlier on, that is exponential I theta defined as cos theta plus I sine theta. If you actually consider theta to be equal to pi, you will see that this function I exponential I pi, let me put pi here, will now be equal to cos pi. Okay, cos pi plus I sine pi. Okay, sine pi is equal to 0, so this side turns to 0. Cos pi is negative 1. Okay, so you can see that exponential I pi will be equal to negative 1. And then you can also consider some other time, but in general you will actually see that whenever theta is equal to pi plus 2 pi m, and of course for all integer values of m, this exponential function is actually going to be equal to, okay, it's actually going to be equal to minus 1. Okay, so in place of this minus 1 you see over here, we're actually going to be replacing it with this function right here. So if we do that, natural log of negative 3, which we got to be equal to natural log of negative 1 plus the natural log of 3, we can now write as the natural log of exponential I, okay, pi plus 2 pi m, okay, then plus the natural log of 3. So that if I bring down these powers right here, I'm going to be having I, okay, into pi plus 2 pi m, and then of course natural log of e plus natural log of 3. And then natural log of e is equal to 1. So I'm going to be having I into pi plus 2 pi m, then of course plus natural log of 3. Okay, then at this point We can now go ahead to replace these in the value of x which we got, and of course we got x to be equal to I minus I, okay, natural log of negative 3, and then of course divided by 2 pi k. Okay, so if we substitute this value of natural log of negative 3 right there, what we're going to be having is that our x will now be equal to negative I into I, okay, bracket pi plus 2 pi m, and then of course plus natural log of 3, all divided by 2 pi k. And then moving on, if I multiply through this I multiplied by this I will be equal to minus 1, and then minus 1 times minus will be equal to plus. So what I have is pi plus 2 pi m, okay, and then of course minus I multiplied by natural log of 3 will give us natural minus I natural log of 3, then divided by 2 pi k. So this is actually going to be the value of x, and obviously you can see here that x is a complex number, because of course you can see from here that this is the imaginary part and then this is the real number part. So let me know if you've understood the solvings. If you've got any value in the video, do not forget to subscribe to our channel, like this video, and I'm going to see you guys in my next video. Bye.